The topic is the definite integral, and it's just a review of summations and the sigma notation. So here's the definition. If am plus 1 all the way to an are real numbers, and m and n are integers, such that m is less or equal than n, so remember m and n are integers, then sigma of ai is equal am plus 1 all the way to an. So let's do example 1. Example 1, we need to find sigma of I square from I equal 1 to 4. In other words, the sum from I equal 1 to 4, I is called the index of the summation. So what this means, it's the summation from I equal 1. So when I is equal 1, we plug 1 into y square, we'll get 1 square, plus when I is equal 2, we plug it into I square, we get 2 square. So I equal 3 square, plus I equal 4 is 4 square. This is what we mean with the definition. So when I is equal 3, so these are the terms. And then here, all you need to do is just add them up, which is equal to 16 plus 9 is 25. 25 plus 4, 29 plus 1 is 30. Now for example 2, same thing, we need, well, this time we need to go from 2 to n. So when I is equal 1, we started from 2. So when I is equal 2, plug it into I, you get 2, plus when I is equal 3, plug it into I, it's just 3. So 2 plus 3 plus 4 plus 5 plus all the way to the last term will be n. The one right before it is n minus 1, and then n. For example 3, well, example 3, the reason why I use this example here is just the index doesn't always have to be I. I is just a dummy variable. We could use j or k sometimes. So usually we use I, j, or k. So let's use j for this one. This says from j equals 0. So when j is equal 0, you plug a j 0 into j. So this is 3 to the 0, plus when j is equal 1, this is going to be 3 to the 1, plus, and then 3 squared, then 3 cube, all the way to 5. So this is j equal 2, j equal 3, j equal 4, and then j equal 5, right? J equal 4, j equal 5. You don't need to show that, I'm just explaining it here. And then you can just add these numbers. If you add them, it's going to be equal 63. Now for example 4, this is different. There is no I here. It's a constant. What this says, we need to go from 1 to 4. So for I equal 1, we just have 6. There is no I in there. Plus, when I is equal 2, we just have a 6. It's always constant. Plus 6. Plus 6, so this is I equal 3, I equal 4, that's it. So, and this is just 6 times 4, which is 24. For number 5, we need to go from 3 to 6. So when I is equal 3 means whatever you see I, plug the 3. So 3 plus 1 over 3 squared minus 5. So we plug 3 for each I. So this is what we mean with I equal 3, plus when I is equal 4, we plug the 4 into each I. So 4 plus 1 over 4 squared minus 5, plus when I is equal 5, you'll get 5 plus 1 over 5 squared minus 5, plus when I is equal 6, you'll get 6 plus 1 over 6 squared minus 5, which is equal to 1.98. Now, that's what the last example is actually the same thing, except if we go from 1 to n, this is how you're supposed to write it. So the first term we plug in 1 into I, so that's going to be 1 plus 1 over 1 squared minus 5. Plus we plug in 2 for I, it will get 2 plus 1 over 2 squared minus 5. If you plug 3, you'll get 3 plus 1 over 3 squared minus 5. And then we keep going all the way to the last term n, which is n. We plug n for I, so n plus 1 over n squared minus 5. And that's it for these examples.